you guys choose what room it is and what size it is, okay? So what room are we wanting to look at for this particular example? Kitchen? All right, kitchen it is, I guess. How big is our kitchen? How many square feet? 400?
Yo, damn, you're rich, Carly.
450 square foot.
Well, our kitchen is just 20 square feet.
No, that's pretty big.
Yeah, that's.
But there you go. All right, so 400 square foot kitchen. Now, the first thing that we should be looking at is how much actual light would I expect there to be outside? And that'll help me size exactly how many windows I need, how much square footage of window space I need. So, we're designing for Las Vegas. Las Vegas is located at 36 degrees north latitude. Okay? So, let's look at our latitude here. And let's draw a line at approximately 36 degrees. And the straighter you can draw your line, the better. This is where having rulers really helps. And I would suggest using them on the quiz. Ruler, straight edge, same thing. So draw a line. Now the next thing we need to do is we need to figure out when is our kitchen open? When are we utilizing our kitchen? Well, think about it this way. A majority of the time, we're actually probably not going to be home when the sun's out. We're probably going to be, out working or doing. But let's assume that we are home 100% of the time. Let's say it's a weekend or it's vacation day or some holiday where we're not at work and we're at school or doing other things. Let's assume that we're at home 100% of the time for at least one day. Right? Because obviously if we're at home, we like to use daylight. If we're at home. So what times would our kitchen be open? Currently we have as options anywhere from 9 to 5, 7 to 3, 8 till 4, 7 to 5, and 6 to 6.
6 to 6.
Probably 6 to 6, wouldn't you say? So I'm going to use this very bottom row. So this very bottom row right here. Now for 6 to 6, we've got options for the amount of daylight that we are guaranteed to meet or exceed our outdoor illuminations at 75%, 70%, 65, 60, 50, and 40. Which percentage should we go with? 75? All right. 60?
Yeah.
75.
That's up to you guys to decide. If you want to go different than me, by all means. I'm just using this as an example. All right, let's go. I'm going to go 75. So 75%.
When we want 60.
From 6 till 6. Okay? That means that I am selecting curve A. So curve A. Let's go ahead and highlight curve A. And right where we intersect, I'm just going to say I'm right at 400, just to make life simple. So that means outside, 75% of the time, from 6 to 6, I can expect 400-foot candles, more or less. Yes? In this case, that intersection is pretty much right on 400. So in this case, it might be like 402, 403. I would say if you round to like the nearest tens, you're still going to be pretty accurate. So, you know, if you were like right in between here, I could realistically argue, oh yeah, it's close to 425 maybe, because it's halfway in between 400 and 450. When it comes to doing the quiz, I'm not going to be cruel and make it to where it's like, oh, you have to figure out it's at 402.6 foot candle. No, screw that. I'm guesstimating as well, so I'll make it to where like the choices would be, you know, like 400, 450. So I'll make it to where it's so obvious that don't select that. Does that make sense? Okay. So 400 foot candles is what I've got outside. So let's go to inside and figure out exactly how many foot candles I need. So I'm designing for a kitchen. Where's kitchen at on here?
Residences, kitchens.
Probably where it says residences, kitchens. And I need anywhere between 20 and 50 foot candles. Wow, that seems a lot like a museum. Pretty much the same thing. So in order for us to figure out how many foot candles I need, I just take my interior illumination, divide it by my exterior illumination, and multiply by 100%. So let's take our range. We've got 20 divided by 400 times 100%. And then I've also got 50 divided by 400 times 100%. So what do I get with this first number? 20 divided by 400 times 100%. How much? 200. 20 divided by 400.
Yeah, but no. Yeah.
So I get 5%. And at 50, what do I get? 12 and a half. Let's see what my recommended range is, just to kind of figure it out. Well, as you can see, I don't have a 36 degree to choose from as far as the column goes. So you can do this one of three ways. Okay? You can say, oh, I'm between 30 and 40, so I'll take the low end of my 30 degrees and my high end of my 40 degrees and say that's my range. In this case, that's, 1.5 to 6. I could round up or round down. I'm closer to 40, so I can say I'm going to go with 40 degrees, and that's between 2 and 6. Or I can interpolate and figure out exactly what 36 degrees would be based on the values of 30 and 40. I'm not going to go through that. I will send you guys a paper that shows you how to interpolate. Okay? I won't go through it right now. I'll explain it next class. Okay? So I'm going to go with the lazy way, and I'm just going to round. I'm going to say I'm at 40 degrees, so I need to be somewhere between 2 and 6. My calculated value is between 5 and 12 and a half. So I'm going to say, okay, instead of 2 is way too low, and 12 and a half is way too high. I'm going to kind of combine these two and say I need to be somewhere between 5 and 6%. 5% means I'm still within my calculated range. 6% still means I'm in my expected range. And of course, 5 and 6% meets every single criteria that I have. Does that make sense? So I just figured out I need somewhere between 5 and 6% daylight factor. So let's go to the second page and figure out exactly how many square feet I need. So I need somewhere between 5% and 6%. So I'm going to highlight both of these lines. Now how big is my kitchen? 400 square feet. So at 400 square feet, where these 2 points intersect, I draw a line straight down. And I need to be somewhere, I'd say probably around 105 to 125 square feet. And that's if I have completely unobstructed glass. So depending on where I would put my windows, I may have some form of obstruction. Let's say that I end up placing all of my glass in one location, and I've got, instead of this big building that's in the way, let's say I've got a large tree that's in the way. I want to try and be conscious and say I'm going to protect for the heating and cooling that are required for this window. So I've got this large deciduous tree in the way. And let's say that I have, let's say I've got a 50-degree angle here. So 50 degrees from the center of my window, looking up towards my closest obstruction, which in this case would be the wall itself, all the way to the top of my tree. So I've got a line for 60 degrees and 45 degrees. I need to be somewhere in between. I draw a line as close as I can to about 50 degrees as possible. I drop my line straight down, and I move over. And I need somewhere between 200 and probably 230, 240, 200 to 240 square feet of glass. Now, this unobstructed vertical daylight aperture pretty much takes into account a 90-degree sky angle. So what happens if I've got a sky angle that's greater than 90 degrees? What if I've got it to where it is, 180 degrees or 120 or, something that's obviously a lot bigger than 90? Well, you can actually make it to where your glass is a little bit smaller because you have more available sunlight for yourself. You don't have those obstructions like, maybe the ground. What if you had a skylight? You need less skylights because, you have less obstructions. You also have direct light that's coming in. Okay? Does that make sense? So there, I just figured out how much glass I need. Now it's up to you guys to figure out where the hell to put it. Do I do one expansive wall of 200 square feet, continuous piece of glass? Do I break it up into smaller windows? Do I make it to where there's some on one wall, some on another wall? I don't know. That's up to you guys to decide. That's where you guys come in as designers. Yes?
Should there be like another portion we have about size directly or against it directly?
That's where we're going to end up doing some of our experimentations. So we'll get to that point. Yes?
So which chart do we use for the square footage of glass we need?
So in this case, if you have unobstructed vertical glass, you're meaning that you have a sky view angle of 90 degrees, exactly, it's the top. If you have it to where it's anything other than 90 degrees, you continue down to the bottom. Now, for side lighting, and as far as the overall assignment goes, That's as far as you need to go. Do that for, every single room inside of your house, and you've got everything you need for the assignment. Let's say you want to go that one step beyond. You want to supplement your daylight with additional strategies. One of the things that you can do for side lighting, notice that this is the side lighting portion, you can use light shelves if you wanted to. And the light shelf all depends on how big is your light shelf, where is it located in your vertical plane in section compared to your window, what's the angle of it, how deep is your room. All of this stuff actually helps out with figuring out whether your light shelf is actually at an optimal design. Now notice that up here we have two different scenarios. We've got one for clear sky and for overcast sky. For clear sky, we're able to achieve much higher daylight factor percentages compared to the overall distance that light will travel, which makes sense. There's more daylight. There's more daylight that's hitting our light shelf, which means that it's able to travel further. And that overall foot candles that's hitting our light shelf is able to penetrate further, meaning more daylight inside. An overcast sky, there's not as much light that's actually hitting our light shelf, which means less light that's traveling deeper into our building. So it's up to you guys to decide. Do I go with the clear sky? Do I go with an overcast sky and say if I go with an overcast sky, I'm covering all conditions, or I go with the clear sky and say I'm covering most of the conditions because Las Vegas has the majority of the time it's fucking clear. The only time that it's not is when it's raining, like today. It's up for you guys to decide. The less daylight factor that you're able to achieve, the bigger your light shelf will be. The bigger your light shelf is, the more cost it is to produce, and it might end up just making it where it's so big that it's just, cost prohibitive completely. So let's say I'm going to design it for all conditions. So I'm going to design it for an overcast sky. I have a daylight factor of between 5 and 6%. So I'm going to go with the higher value just to make my life simple and split this directly in half. 4, 6, 8. Actually, that would be 5. This would be 6. My bad. Let's actually look at 5 or 6%. Now you'll notice that there are 3 different lines here. Each one of them represents a different placement of where the window is in the overall section compared to your light shelf. It also makes it to where, in this case, this is the light shelf placement in D, so the overall depth of the light shelf, how much of it is outside compared to inside. So line A means that a majority of your light shelf is outside. At least 2/3 of your light shelf is outside. B means it's half and half. C meaning that 2/3 of it is inside of your building. So depending on how you want your light shelf, choose which line you want. In this case, I'm going to say, which one do we want to do? Do we want to have it where the light shelf is outside or inside? Outside? Okay, so I'll select line A. Line A, where those intersect. That pretty much tells me that a majority of the light that is reflected off of my light shelf will be able to penetrate anywhere from 10 to 12 feet further into my building. So compared to my 2.5 times H, I'm able to go somewhere between 10 and 12 feet further, additional, because I'm reflecting that light off of my light shelf. figure out, do I angle my light shelf or do I not angle my light shelf to help optimize how much is actually being reflected? So in this case, I'm going to look at 36 degrees north altitude. And I need to figure out how high is my light shelf in comparison to how deep my room is. So let's say I've got a 20-foot by 20-foot room. And let's say that my light shelf here is only located, let's throw a number out there. Let's say it's about 3 feet away from my ceiling. So that means I have a ratio, if my room is a total of 20 feet deep, I'm 3 feet away from the ceiling, I've got a ratio of 20 to 3. What does that come out to? Twenty divided by 3. 6.67. So somewhere between 4 and 8. And you'll notice that it's, the equation is listed just right here. X divided by h, if we look at the overall diagram, x divided by h. So 6.3 or 6.67, so almost directly in between. That means that to help optimize my light shelf, I need to have a tilt of probably around 15 degrees towards the building. So 15 degrees towards the building. So this angle right here. So underneath these conditions, if I wanted to achieve an additional 12 feet of daylight to enter into my room, I need to make sure that I have 2/3 of it outside compared to inside. So if I had a 3-foot light shelf, I'd have 2 feet outside, 1 foot inside. I would also need to make sure that my light shelf is 3 feet away from the ceiling and angled inwards 15 degrees. Does that make sense? Now, obviously, 12 feet compared to an overall 20-foot deep room, that's not a lot. So is it really all that beneficial to have a light shelf? I leave that up to you guys to decide. It may not be. It may be just completely wasteless. The shallower your room, the less need there is for a light shelf. The deeper there is, absolutely it's needed. Okay? Does that make sense? Questions? Now, if you'll go to the next page, you'll notice that, well, we start off with exactly the same damn thing. This is for top lighting, so you have a choice. Do I go with all side lighting, or do I go with top lighting? I let you guys decide. It's the exact same steps if you do top lighting, so I'm not going to go through this part again. It's the exact same thing, just on repeat. The difference is your supplemental strategy. What kind of light well do you have? And the overall efficiency that you're looking for. The higher your efficiency is for your light well, the higher your percentage of efficiency, the better your window is. The lower it is, the worse off your actual design is. And with this, what we need to know is what's the overall reflectance of your walls inside of the space, and what is your well index. And your well index is this equation right here. It's the overall height of your well times your width plus the length divided by 2 times your width times your length. So this is where you guys can come up with whatever the hell you guys want. All right? So let's say I've got a well, and I'm going to make it to where it's, 2 feet deep, 5 foot by 5 foot. So my height, my length, and my width. Let's figure out what my well index is going to be. So I've got 2 times 5 plus 5 divided by 2 times 5 times 5. So what does that give us?
250.
How much?
250.
250? This should be 20 divided by 50.
Yeah, 4.
0.4. So I've got a well index of 0.4. So somewhere in between these two. So something that's relatively squat compared to y. So 0.4. Now I just need to figure out how reflective my walls are. Well, white paint is typically around 90 to 95% reflective. If you go with any other color or any other material, you can easily reduce that overall reflectance. It all depends on the material. If you look online to the manufacturer's information, it'll tell you exactly how reflective that material actually is. So I'm going to say I'm using white paint, so I'm 90% reflective. Where that intersection is, I'm a little bit more than 90% efficient. I'm probably around 91 to 92. So let's say I had my overall 90-degree sky angle, and I was going with 6% daylight factor. Let's say I'm going with 125 square feet for my top lighting. So if I've got 125 square feet of top lighting at 92% efficiency, that means that I actually need a little bit more glazing, a little bit more window to achieve the exact same amount of light as if I had just 125 square feet with no well on top of it, because I'm not as efficient as 100%. Does that make sense? So in this case, I take 125, I divide it by 92%, so 0.92. 125 divided by 0.92.
135.8.
135.8, so about 136 square feet, more or less. So because I'm not 100% efficient, I need just a little bit more glass. So if I went with, 5 foot by 5 foot pieces of glass, each one 25 feet, how many skylights is that? So 136 divided by 25.
5.
Somewhere between 5 and 6. If I went with 5, I would actually be a little bit less than 6% daylight factor. If I went with 6, I'd be more than 6%. Does that make sense? So, pretty straightforward to kind of figure out, isn't it? Now, again, you'll have to follow these steps for every single room. Now, if you have a space that's completely open, but you have it towards like, this area is the living room, but this area is the dining room, but there's nothing that's actually obstructing anything in between. If you want to, you can consider them to be 2 separate spaces or 1 large space. It's up to you guys to decide. How you guys justify everything is all up to you. not going to prescribe you anything.